Hello guys, welcome to the DMS online school. In today's lesson we are going to continue with mathematics, and this is mathematics lesson 3 on computers. And in today's lesson we will be looking at converting from pseudocodes to flowcharts. All right, and we'll be using examination questions as examples. All right, so we have a question which came in 2023 general certificate, that is GCE. All right, so the question reads, the program below is given in the form of a pseudocode. So this is the program here. So it has begin, enter n. If n is less than 0, then display error, n must be positive. LC sum is equal to n over 2 times open brackets 2 to the times a plus open brackets n minus 1 close brackets times d close brackets. And if display sum end, draw a corresponding flowchart for the information given above. Yeah, so this is what we are going to do here, guys. So we will be able to convert this here, which is actually the pseudocode from begin up to here, into a flowchart. All right, so you must understand that the begin is represented by oval here, so you need to have oval. So this is a flowchart now I'm writing. So oval represents begin, and then it has to be begin. You see, it can either begin or start, so we can write begin there. Then this one here, enter. This one, which is an input device like a keyboard, a mouse, and everything like a microphone. We said an input device, which stands for enter or input, is represented by a parallelogram. So here you need to draw first the arrow down here and put the parallelogram, and then type this one inside here, enter n. Okay, then here they're saying if n is less than 0. So where they say if n is less than 0, this is a condition where a decision has to be made. So you need to bring a diamond or a rhombus, I think here, like this one here, arrow. This is for a decision here where they say if n is less than 0. So what you are going to do, you're going to say any so where they say if n is less than 0, instead of saying if n is less than 0, you say like here, you put is n less than 0 with a question mark here. Okay, so this is a condition. So if that is a question, remember with a question you need two answers, either yes or no. So usually why they've put a condition like this is to make sure that a program goes in the right direction. Any input which is wrong, then it is going to reject. Like you enter n here, then this n should be checked to say is n less than 0, so it has to be checked, this n. If it is less than 0, then you say if it is less than 0, yes. Then what happens? Display error, okay, is if n is less than 0, then display error, n must be positive. So meaning then it means yes. If n is less than 0, then display error, n must be positive. So it means yes here. So yes, so then you are going to write this one here. Okay, so this parallelogram stands for either input or enter. So I mean output or enter. Yeah, so this one here, it is enter here, then here it will display. So here the message will be displayed, display error, n must be positive. This one here, display error, n must be positive, meaning that the program will not continue to do what it's supposed to do. It will terminate, okay, because the value of n is not valid. But if no, which means else, then you go ahead here. So then you find sum is equal to this. So now this sum here, it means the computer will start processing after entering the correct value of n. If you enter n, it is checked is n less than 0, no, meaning the value of n entered is correct. Then the computer program will go ahead to calculate the required value, which is sum. So sum will be put here in the rectangular box, which represents process here, meaning the computer will be now processing in the processing unit, the central processing unit, which is the CPU. So meaning you enter this one here so that it is the one it is going to process on, because the value of n is a valid one. Then after it does that, then this one here, end if, does not matter, meaning it will end. This one actually end if ends just here. Okay, then you go to display. So you go down here. So I said display, like this one and this one and this one, they are all represented by parallelogram. So you write a parallelogram here and you put display sum. Then after it has displayed sum, after calculating it here, it will display sum. So meaning after you put the correct value of n here, it is accepted that this n is not less than 0. It is going to be placed here. N will be placed here. It will be placed here. Then if d is a constant, also it is not placed here. It will calculate the sum and put it here. So it will allocate that sum to sum here. Then it will display. When it displays sum here, it means it will display the value which will be calculated here. Then after that, you go to end. End is represented by the same symbol here. So you go like that, you say end, you write it like that. So this is how you proceed from the pseudocode to the flowchart. Yeah, so let's move to another question here. Yeah, sorry. So here you need to connect this to here. You can't leave it like I see the videos on YouTube, or rather in books, some lessons, some books, they just leave it here. No, you don't need to leave it here. Why you don't need to leave it here? Because this is a program. So once a wrong value is entered, then the program will proceed to stop. So meaning the program will display error n must be positive, and then it goes to stop. Okay, that's what it does. But such kind of programs like these ones here, they are not very good, which definitely go direct to stop. So you can't leave it like that. So the program doesn't go like that. So you need to show direction how it will go. So it will go like that, meaning after you have entered a wrong value which does not satisfy the condition, then the program will display the error and directly go to stop here. Just like here, there's display and stop. Even this display and this display, they are playing the same role, except this display is displaying the correct value here, but this display is displaying the wrong, actually, a value entered here. So then it displays exactly that, and then it goes to stop the program. So it will not proceed. But here, if yes, it will do the sum here, then display the correct sum here, and then stop. So this one must proceed to stop, as well as this one. After this display, which is corresponding to this, it goes to stop. This one also goes to stop. Except here you don't have the process, because there will be nothing that this program is going to process after a wrong value of n has been entered. It will not process anything. It will just go to stop. But the correct one, meaning it will find the sum here, then it will proceed to display the correct sum, and then it will go to end here. All right, so let's go to the other example here. So this example is coming from a 2022 General Certificate, which means GCE, and this is the question which says study the following pseudocode. So this is the pseudocode again provided here. So we have start. So under start, there will be enter, R capital, then R small letter, then L, then here if R is greater than, if small letter r is greater than capital R, then print error, the value of r is not valid. Else s is equal to pi times open brackets capital R plus small letter r close brackets times L. end if print s, then stop. Yeah. So again, here you have seen that we have print, and then here we have print. So display, they can either use display or print, and then here they can either use start or begin. Here they can use stop or end. Then here they can use where there's enter, they can also use like input. Then here where there's the yeah, so here where there's input, where there's print, here they can also use output. Okay, those are some of the words that can be used interchangeably. So this is the program which we have in pseudocode. Then they're saying construct a flowchart corresponding to the pseudocode above. So we need to construct a flowchart corresponding to this. So as usual, start should begin with the oval start there. Then we proceed to enter. Enter here is represented by the parallelogram like that. So you type this one here, enter, capital R, small letter, letter R and L there. Then this one now where it says if small letter r is greater than capital R, meaning this is a condition. So you write this one, you say is now. If changes, so you say is, sorry, here it should be R, not any. Let me change it quickly. Yeah, I've changed it. So is R, is a small letter R greater than R. So this one here, if changes to is. So you say is R, small letter r greater than capital R. You even put a question mark. So then here represents yes, meaning you have agreed to this. If R or if small letter r is greater than capital R, then so you say here you are asking yourself, is R or small letter r greater than capital R? You say yes, which is for then. Yes, then what comes next is this one. Then print error, the value of error is not valid. So in this print here, print always, print display, enter, use the same symbol, parallelogram. So this print will have with a parallelogram there, then you enter this word here. Print error, the value of error is not valid. Then else here, else stands for no. So no here. So meaning no. If no, then what else? Else means no. Then you do S is equal to, which S stands for surface area, is equal to pi times open brackets capital R plus small letter r close brackets times L. So here now, this one represents now the processing, meaning after you enter capital R, small letter r, and L, then they will be need to check these two, where after you enter them, they will check is small letter r which you entered here greater than this other r which you entered here. If yes, this is what will come out. If no, then it will proceed, meaning you have entered the valid value or the valid values, yes. So it will proceed to calculate the surface area. So calculating, which is processing, is represented by a rectangular like that. Then you put this one here from here, okay? So you put S is equal to pi times open brackets capital R plus small letter r close brackets times L like that. Then and if it ends, and if you don't indicate it, then you proceed to print S. So after it has put the value R here, it will put this one also here, it will put this one here, calculate the sum, put it into S, then it will go directly to display here. So here you say display S or print S, meaning whatever was calculated here was pushed into S, then here display S, meaning S here will display what was calculated here, which is here. Then here stop, meaning the program will stop. So use the same over here like that, stop. So the program will stop like that. Now again, just as I said, if you entered wrong values for capital R and small letter r, then the process will just print error. It will display print error. Then it will definitely stop. So it will connect to stop here. So this one, just as I said, this and this, they are all connected to, since they are all saying print, this one is connected to stop. This one also must be connected to stop, except this root calculates a value. This root has no calculations, so it just stops. It doesn't do anything. It comes back to stop here. Okay, so that's what you should understand. Yeah, so let's go to another example. So this one came in 2020, yeah, general certificate. So it says the program below is given in the form of a pseudocode. So we have start, enter radius. If radius is less than 0, then it display error message and re-enter positive radius. Else enter slant height. Okay. Then if a slant height is less than 0, then it display error message and re-enter positive slant height. Else area is equal to, I think I have to remove something here. Yeah, so I've removed the multiplication here. So area is equal to r times open brackets r plus slant height. Okay, so maybe there's something missing here, but that doesn't matter. And here we come to end if, then display area, then stop. Then the question now says construct a flowchart corresponding to the pseudocode above. Okay, so yeah, so we'll start. As usual, start is represented by the oval. We'll put start there. Then enter radius. So enter is represented by the parallelogram. We'll put parallelogram down here like that. Then also enter radius. So enter radius, we can just use a symbol here r, so that to avoid wasting much of the space. Then after that, if radius is less than 0, meaning this is a decision, so you write parallelogram, you write diamond or rhombus there. Then this, if radius is less than 0, it changes. You say is radius, which is r now, less than 0. You're asking is r less than 0. Now there will be two answers. Like then actually stands for yes. Then here else stands for no. So then, so meaning if yes, which is then what happens if yes? So display error message and re-enter positive radius. So you write this one for display. So you write here, this one here, from here up to here, display error message and re-enter positive radius. Now, after you do that, you have seen that I've said re-enter. So this program is a very good program. That's why I said that those others which goes to directly stop, they are not good. This one, it wants a person to do the right thing. So where it says re-enter positive radius, meaning after a person has entered the wrong error here, which is negative, then the computer will reject it. The program will reject, will show, it will display error message and re-enter positive radius, meaning it will guide this person to ensure that this person enter the correct. So once this one is entered, it will be checked. Is it less than 0? Meaning if it is less than 0, that means it will be negative. If it is yes, then it will say display error message and re-enter positive radius. So it will require that the positive radius is entered. So meaning this program should go back here. So you draw this one here, you show it there, that this one goes back where a person will need to re-enter until, if a person again enter the negative, meaning this one will just be going like that in rotation. But if a person now enters the correct radius, which is positive, then the direction will change. Like in this case, if a person enters error in the first place and that error is checked, here is error less than 0. If no, like here no, then what happens? They're saying enter slant height. Okay, meaning else enter slant height. So here enter enter is similar to this one, so even here we'll write the same one here. So we'll enter height here. So I've abbreviated, I've not used this one, so you just say enter height there. Then again here you see there's if slant height is less than 0, meaning there's another condition here which will use a rhombus or diamond here. So say okay, diamond here. Then also ask here if slant height is less than 0. So here we'll say is, which is h standing for slant height. So is h less than 0. So they are saying then display, meaning it is yes. If slant height is less than 0, then display, meaning yes. You have said then, meaning you have said yes. Then it will display this message here. So it will display in this same one for displaying a display error message and re-enter positive slant height. So here it will be display error message and re-enter positive slant height, meaning again after a person enters or enter error, it will be checked until they have agreed, oh, the error you have entered is okay. Then it will proceed, it will ask again, enter h. Again, that h again should be checked. Is this h less than 0? If it is discovered that this h is less than 0, then they're saying no. It will say display error message and re-enter positive slant height. So meaning re-enter again, you go back here where the first one was entered, meaning this process will go back here, okay, where you come until you enter here. Some program can just connect from here. It should come direct to this one here, okay, from here to here. Okay, some can connect it from here direct to here or here. It is the same. So here this one also can be connected direct to here or to there. It doesn't really matter. So here it will ask this person if he has entered the height, slant height, which is less than 0, which means it will be negative. If it says yes, it will say that is error. So it will ask the person again to re-enter. If a person continues entering negative, then it will continue displaying this. The person will not move out of this loop, will just be looping through, okay, until enters a positive. So that value, if it will be entered, it will be checked is h less than 0. If it will be no, then it says else, meaning no, area is equal to pi times, r times, open brackets that. So you say, okay, no, then you come to this. It will process this. So processing, you use a rectangle. So you enter here, area is equal to this, okay? Then what happens, end if. So you end here, end if, then display area. So you come to display. So display, which is represented by this parallelogram, should be written here. So you say display area, then after that you go to stop. Okay, stop is represented by that. So it will be stop like that. Yeah. So basically this is what should be done here. Yeah, so we have converted this pseudocode into the flowchart. So guys, if you're enjoying this video, give it a like and let me know in the comment section. If you haven't subscribed to this channel, consider clicking on the red subscribe button below and turn on the bell notification so that when I post another video like this one, YouTube will be able to notify you. Again, guys, thank you very much for watching. Please consider sharing this video to as many people as possible in the groups where you are. Yeah, so let's proceed. We have this question which came in 2019. So this one is a task for you guys. So you need to do this one. You guys who are in the mathematics online group, you can answer this one and submit for checking, and also answer this one which came in 2021 and submit for checking. Yeah, so you submit also for checking this one here. Yeah, so for those interested in joining mathematics online revision, please you can contact me on the line 0977 92 41 75 at 50 kwacha only, guys. It is 50 kwacha. And those interested in GCE 2024, you can also contact on the line 0977 92 41. GCE online lessons for mathematics are going at the 60 kwacha only. Guys, thank you for watching. As for now, bye and see you in the next revision.